Hello, this is Britt Caswell with another example video. In this video, I'm covering Example 2 from Section 3-2 in the SavvasRealize Algebra 1 textbook. So in this example, we are looking at writing a linear function rule when we are given a table. Alright, so when they say a linear function rule, all that they're saying to do is to write the equation that would produce this table. Most of the time, we're going to be using the slope-intercept form because often we care about that y-intercept. I could also use the point-slope rule. That's also okay. So in this case, I want to go about finding my slope and my y-intercept. Alright, we have a problem where they're making bracelets, and they have shown the cost of making the 4 bracelets that they have on the table. And the function rule, or the equation, will be showing how to calculate it for any number of bracelets. So my number of bracelets is my x value and my cost is my y value, because I need the number of bracelets to determine the cost. Now recall that to find the slope of an equation, I need to find the change in my y values and subtract my change in my x values. So what I'm going to do is I'm going to be kind of counting how much these are changing by. So to go from 1 to 2 or 2 to 3, alright, I am adding 1 to my x value over and over. Now for my y value, to go from 17 to 32, I'm adding 15. From 32 to 47, I'm adding 15. I'm adding 15 here. So as long as this is a constant change, I've already subtracted my y's and x's. So I could just say this is 15 over 1, which if I reduce that fraction is just 15. So where my m is in this equation right here, I'm going to replace it with the number 15. So then I need to go ahead and find my y-intercept, okay, which is the initial cost for all these bracelets. Okay, so in order to find that, I'm going to pick one of these sets of ordered pairs and plug it in to find b. Alright, so I'm just going to keep it simple. I'm going to do 1 and 17. So where the y is, I'm going to write 17. Where my x is, I'm going to write a 1. And then I'm just going to solve this equation out. So first I'm going to deal with that parentheses. So 15 times 1 is 15. And then to isolate b, or to get b alone, I'm going to subtract 15 from each side of the equal sign. So I get 2 as my b value, which is what I'm going to add right here into my equation. And that came from right there. So the equation, or the function rule, is this right here. Let's go ahead and let's try it with another table. So again, I need to find either y equals mx plus b, or I can use y minus y1 equals m times x minus x1. That's also acceptable, okay? And I could put it in point-slope form, which is easier, and then convert it to slope-intercept form if I want to. Either way works. So first let's find our slope. So my slope in this case is my change in my y's. So if you notice, this is increasing by 6.5 each time. So my change in my y is 6.5. Now my change in my x, going the same way, I'm adding 1 each time. So I'm going to put a 1 here in the bottom. So my slope is 6.5 divided by 1, which is just 6.5. And that's what I'm going to write into my point-slope form. So again, I'm solving this in a different way. just for the sake of helping you guys see other methods. I can plug this slope into here and then do the same steps that I did last time, where I plugged in a point and solved for b. That's okay. So now for my x1 and y1, I'm just going to go ahead and pick one of my points and plug it in. I think I'm going to go with this one, 1 and 6.5. So where my x1 is, I'm going to write the number 1. Where my y1 is, I'm going to write a 6.5. Alright, now this is the function rule. This is an acceptable function rule. Now if they ask me to write it in slope-intercept form, we can do that. Alright, I can distribute the 6.5 to the parentheses, which gives me y minus 6.5 equals, so 6.5 times x is 6.5x, and 6.5 times negative 1 is minus 6.5. Alright, and then to get the y alone, I'm going to add 6.5 to each side. And that gives me y equals 6.5x. So that's another version of the function rule, which is completely acceptable. Alrighty, so now let's look at step B, or example B. So again, first I'm going to find my slope. So my change in my y, I am adding 3, adding 3, adding 3. So I'm going to have 3 over, and then my change in x is just like the last one, where they're adding 1 each time. So my slope that I'll be using is 3 over 1. So this time I'm going to use slope-intercept form just to show you guys one more time how to do it. So where the m is on slope-intercept form, I'm going to replace it. Oh, I could just write a 3 there. I'm going to replace it with 3. So then to find my b value, remember, I just go ahead and I plug in the slope and one of the points into the equation. So I'm just going to choose the point 1, 1, because I think that looks a little easier. So where the y is, I'm going to write a 1. So I get y equals 3 times x, which for x I'm just going to write a 1, plus b. So then here, 3 times 1 is 3, so I have 1 equals 3 plus b. And then to isolate b, or to get it alone, I'm going to subtract 3. So I get negative 2 for my b value. So here on the equation, I'm going to erase plus b, and I'm going to write minus 2. And so that's my function rule for this example. Alrighty, until next time.